So welcome back. So in the last chapter, in the chapter 5, we talk about the predictor, where we learned how to take our trained AI, export our model, and use the predictor to analyze the new images or videos, getting results like bounding boxes. So now that our model can make predictions, it is crucial to know or understand whether our prediction is good or not, or whether it is accurate or not. So how do we know if the model is actually good at making those predictions? We'll discuss this on our validator chapter. So the important question includes: does it find the most of the objects it should? Does it correctly identify what the objects are, and does it avoid finding things that are not really there? So validator evaluates the model performance on the validation datasets. So like different matrices are used, for example, mean, average, precision. So this also vary between the our. So if we are doing one thing or other, then it can vary. So the matrices can vary. So for example, this mean, average, precision, it can be used for the detection or for the segmentation tasks. We can use intersection over union and other matrices. So this validator, it actually ensure model generalizes to the new data with or it must capture whether it is working or not. So it is generally used after training or for the benchmarking. So think of the validator as the judge or a scorer for your AI model after your model has been trained. So, or even during the training, you need a way to measure its performance, whether it is doing good or bad objectively on a data. So, for example, we are talking about used after training. It is not usually only after the training for benchmarking, but also when we are running the models or when we are just doing the validation, we also use different validation tools in order to ensure to update the weights so that the results are good and under the certain limits. So even the perform it measures performs objectively on the data, so it has not seen during the training phase. The validator does exactly this. All right. So it takes a trained model, it takes a set of data specifically set aside for the validation, like the validation set from your data set. Next, it will use that data or the model to make the predictions on the validation data. After doing that, it will compare these prediction against the known correct general truth, like ground truth labels for that validation data. After using having that information, it will calculate the specific performance matrices based on these connections. So for tasks like detection, the common matrices are precision, recall, and MAP. So for example, we have two positive, two negative, FP and FN. So these are the description. So as I mentioned, there are different matrices which are useful for certain tasks and which can vary as well based on our requirements. So for example, this precision, it will talk about how accurate the models have the positive predictions, like when it says it has found a car, is it usually right? That is a question. So for example, if it is saying that it has predicted waste, then if this is a yes, if that is a waste, then it is a true positive, that is correctly identified. But this is not always the case. There can be the different combination of different probabilities and the different things that can occur here. So then recall, another recall is how many of the actual objects did the model find. For example, there are many cars, as we see in our first chapter, there are many cars in the data set. So whether it has found all the cars or whether it has missed some, that is a question. So it can be calculated by using the recall. Whereas MEP is a single number that combines both precision as well as recall over different confidence levels. Like 50% confidence, like intersection over union would be calculated for that. Whether for different probabilities like 50% or between 50 to 95 percentage or something like that. So this is not going to be discussed on detail. For giving you the brief information only being talked here. So how the validator scores? So let's talk about the basic idea. All right. So the main way we interact with the validator in this analytics or YOLO model is through the .val. This is the val function, and this is loaded in the YOLO model object. So for example, we have created here model YOLO model, and uh, it is being loaded with a model. So then here is this is a simple example. You can see the model. So we have our basic model like a trained model, we have our trained model. Then we use the validation on the data set. Often the model remembers the data set it was trained on because it was trained on this data set. If not, we have to specify the data argument, like in training we have to specify, we have to do the different things. So matrices, we can see here matrices, this is the key step, all right, and we call this dot val method on the model. This is a function, and this tells the YOLO to set up and run the validation process. By default, if the model was trained on a specific data set, like it can be defined by configuration such as data.yml file, it will remember and use that val. So for example, if we look in the chapter 2, we discuss about passing the folder for the training and the validation separately, so it will remember here. And if the model file does not have that information, it is just the architecture words, that information is only about the weight. Or if you want to validate on different data set, you can pass by using the this data path and all the arguments, otherwise it will remember, or it will use the default settings. So next is the matrices. You can see the matrices, here is a matrices function, or here you also can use, you can see matrices function. So it is something that is being returned, returns the model, or this val method will return an object. So here we call it, or we define it as a matrices, the variable name. It was all the calculated performance score, like yeah, MAP, recall, precision and everything, and then later we can print those values. And we access the specific matrices, and we can calculate just like the predictor. We also can configure the validation process using arguments passed in this model.val. And these, as mentioned earlier, these arguments will override the settings or settings remembered by the model. So there are also different types of validator based on the based on the performance or the necessary. The best validator is a blueprint. So for example, it will define the standard steps, what should be done, or that apply to any task, like for example, loading the configuration, that ML file, or setting up the device, or even loading the data set, running the model inference loop, or accumulating results over those batches, and finalizing those matrices. It handles this validator, it handles the core structure. So other is the task specific validators are also present, which like detector validator, segmentation and classification validator, which inherit from this base validator. However, they have implemented their logic, unique logics. So for example, how to interpret the model's raw output for that specific task, how to compare task specific predictions like detection boxes, segmentation marks, or the classification probabilities to the task specific ground truth levels, or even how to calculate the relevant performance matrices like MAP, recall, or precision for the classification, or even other for the other things. So when you call this a model.val, we talked before, this YOLO object automatically selects and initializes the correct task specific validator, right? So whether it is our segmentation work, or even our detection or classification, the model will understand and it will call. So therefore, looking our workflow, we can see how the task is being created here. So we can see the process here. So for example, we can see the initialization where the validator receives the so we initialize the validator and the raw data set, and the validator will receive the model instance and configuration settings from the user model variable. And this then we have the data set setup. So it loads the validation data set based on the provided data path in the configuration. Like this will involve setting up objects like dataset abstraction, which can efficiently load images and the labels from the validation folders. So for example, we model validation would pass here, and then the set of matrices tasks, then the loading the batching images, pre-processing, and this is a loop. For example, the validation loop, we have our validation loop which initialize the object of variables needed to accumulate the statistics across the entire validation set. So example, list to store the predicted boxes and ground truth boxes, or it counters the correct classification. Like, and validation, this loop will iterate through the validation dataset, like usually for the batches. For example, for a batch, this loop will be set up. The batch will be loaded with their labels, then it will be pre-processed, and then it will be compared with the ground truth, and then the stars will be updated, and up for the next batch the process will be done, and finally the final matrices will be calculated. So everything will be saved in the list or something like that, and this is the process. So we have to understand how it load the batch and the corresponding ground levels. We need to understand, like in the pre-process there is a resizing as well as normalization, and this will be passed to the model to get the predictions, and these models will use the underlying inference capabilities like a predictor, and then it will be process the raw model output for the batch using the taxi specific logic, like we talk about applying NMS for the detection, and then comparison with this comparison after the starts, like counting the true positives, false positives, or the false negatives. This will be done here, and after once all the batches are completed, the validators use the accumulated statistics to calculate the final overall performance statistics like MAP or accuracy. The validators will then compile these final matrices into the structured object and it will return it. So I think I have also included the pictures of this, how the base validator and the functions will be calling. So for example, for the base validator, we'll get the data and will be processed, will update the matrices, so this is the, our class, and then how the detection validator works. For the detection, the matrices are calculated based on the details on, and how these functions are calculated. So this is like a common evaluation framework. Okay, so in this chapter, so next will be the chapter 7. In this chapter we learned about the validator, which is the essential component in the YOLO for measuring the performance of a trained model. We also see how to use the model.val method to initiate the validation process, like which compares the model's predictions on the unseen data against the ground truth labels. So this validator, it calculates standard matrices like MAP for the detection task, and gives the quantitative scores for our model's accuracy. So these are the quantitative scores. So we also looked under the hood, understanding the roles of base validator and taxi specific validators, and the general workflow of iterating through the validation dataset to accumulate statistics and calculate these final scores. So now understanding the validator is a key to knowing how well your AI expert performs, and in the tracking the improvements. So this evaluation process is not only done manually after training, but it is also a critical part of the training process itself. In the next chapter, we will put all together and explore the trainer, the component responsible for learning process that uses both the dataset and the validator. Thank you so much.